Sir. Tak dengar suara sir.
Thank you. Okay, so soalan satu tadi, dia punya jawapan yang dua ni, okay. So jawapan yang dua ni lebih pada disadvantages. Yang lain ni lebih pada disadvantages of closed loop. So if you have these 2 points here, you get 4 points, 4 marks for question 1. Okay, now we move on to question number 2. Okay, so we have learned about reducing block diagram. We have 6 rules, okay? So 6 rules for block diagram reduction. So rule number 1, we need to look for cascade. And then rule number 2, for parallel. Number 3, feedback. If you cannot find any more of these 3, then you need to shift pick-off point to the right. And then number 5, shift summing junction to the left. And lastly, repeat the process until you get a simplified block diagram. Okay, so let's look at the figure 1b. So in figure 1b, so we have feedback here. And okay, that's it. Okay, then we need to simplify this feedback. And then after you simplify the feedback, then you need to go for rules number 4 and number 5. So if you look at rules number 4, you need to shift pick-off point to the right. So you can take this pick-off point and shift to the right. Okay, so let's simplify these 2 first, okay? Okay, so you shift this point to the right, so you get G4 over G2, and then feedback, you get G3 over 1 plus H3 G3. Okay, then from here, you can see that these are parallel, and these two here is cascade plus feedback. Okay, so let's simplify these two first. So step number 3, parallel, and number 4, cascade plus feedback. Okay, and then from here, you will see that the top here is cascade, and then feedback with unity feedback. So step number 5, cascade, and 6, unity feedback. So the transfer function y over x equals okay, simplify, you get okay. So this is the answer for question number 2. So if you have these first two, feedback, shift takeoff point, parallel, cascade feedback, this one cascade unity feedback, and the final answer, so you get 6 marks. Okay, so 1 mark here, 1 mark here, 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 and here. Okay, And then question B, from your answer in A2, sketch the root locus of the system for k from 0 until infinity by first determine the poles and zeros, the asymptote, the break-in and breakaway points, and let G1, G2, G3 equals 1, G4 equals S minus 2, H2 equals S, H3 equals S squared minus 5. Okay, tengok dulu. So substitute the values. Okay, so determine the poles. So poles when k equals 0. So S equals, so you get denominator equals okay, so equals 0, you get S. Okay, so poles is at -2, -1, 2. Okay, zeros is when k equals infinity. So you get S equals 1 for poles, okay? and then determine the asymptote. So the real axis intersection, you use the formula sum of poles minus sum of zero divided by number of poles minus number of zero. So here you get minus 2 minus 1 plus 2 minus 1 divided by 3 minus 1. So negative 1. And then the angle, apa tak formula lupa dah. Okay, so if k equals 0, you get theta A equals pi over 2. K equals 1, you get theta A equals 3 pi over 2. So k equals 2, you get theta A equals okay, so this is exceeding 2 pi already, so we don't want this. Okay, so the angle of asymptote is at k equals 0 and k equals 1. Okay, and then determine the breakaway breaking points. Okay, sum of 1 over sigma minus j z equals sigma summation of 1 over sigma minus poles. Okay, and then here is 1 over sigma minus 1 equals 1 over sigma minus plus 2, 1 over sigma plus 1 plus 1 over sigma minus 2. Okay, simplify. Okay, panjangnya. Okay, saya dah tak tahu dah betul ke tak. This one will be alah, kena guna calculator. Tak ada calculator kat sini. Okay, nanti check. Okay. So the breakaway point should be positive. Kat sini untuk yang ni breakaway point dia positif. Okay. Negative, sorry. And you will get three points. So from the root locus later, you'll take the negative. Okay, and then we can sketch the root locus. So the poles is at -2, -1. So here -1, -2, 2, and 0 is at 1. Okay, so and then the asymptote is at -1. So asymptote is here. And the angle is 90 degree and 270. So here and also here. And breakaway is positive, it's somewhere here. And I think you'll get 2 more points, maybe here and here. Good. Okay. Okay, then we can sketch the root locus. So the first rule is it will start from poles. So start from poles and at 0. So your root locus will start here and go to this pole. And from pole go to this 0. And then since your 0 is only 1, so you need to add 0 at infinity. So these two poles here will go to the breakaway point here. And then it will break away and then will go to infinity. So it will go out and go to infinity. But we'll never intersect the asymptote. Okay, so there are 3 branches here. So 1 branch here, the 2 is here. Okay, symmetry about the real axis. Okay, so for the marks, you get 2 marks here to determine poles and zeros. And then 1 mark here for asymptote on real axis, and 2 marks here for determining the angle of asymptote. And then you get 3 marks here for breakaway and break-in point. And then for the sketch, if you have the poles and zero plotted on the S-plane, you get 1 mark for plot pole and zero. And then 1 mark for symmetry. Okay, this is the symmetry. 1 mark for 3 branches. And 1 mark for arrow direction. Okay. So semuanya 12 markah. Okay, so question number 2. Based on the root locus that you have plotted, comment on the system stability. Okay, kita lukis cantik sikit. Okay, so if you look at this root locus, you will realize that at k equals 0, which is at poles, so the poles is, there are 2 poles on right hand side and 1 pole on left hand side. And when k equals infinity, which is at 0, so there is 1 0 on left hand side and 2 zeros at infinity on the right hand side. So if you look at the value of k here from k0 to k infinity, the poles, if you plotted the poles from k equals 0 to k equals infinity, the poles, there will be always poles on the left hand side of the S-plane, meaning that if you vary the k from 0 to infinity, the system will produce poles on the left hand side. Ni left kan, ni left, ni right, okay? On the right hand side of the S-plane, meaning that for any value of k, the system is unstable, okay? So you can say from the root locus, for k from 0 to infinity, the poles or root locus will have sections or branch on right hand side of S-plane. Therefore, system is always unstable for k from 0 to infinity. Okay, so if you have this comment, you get 3 marks, okay? Okay, so let's move on to the next take-home quiz. Okay, take-home quiz number 2. So question A, describe how would you determine the stability of a control system from a root locus. So this question asks you to describe how you can determine the stability of control system from root locus. So we know that root locus is a plot of poles for k from 0 to infinity. Okay, or maybe from negative infinity to infinity, okay? So we can say that from 0 to infinity. So when k at 0, then it will plot, the root locus will start from poles, okay? Let's say from any poles. And when k is infinity, then the root locus will end at any 0 in the transfer function. Okay, closed loop transfer function. So you can say that if the root locus macam mana cakap, okay, at k equals 0, if root locus lies on left hand side of S plane, system is stable. Continue. For k from 0 to infinity, okay, if root locus lies on right hand side of S plane, system is unstable. Meanwhile, if from 0, if k from 0 to infinity and root locus intersect JW axis, then system is marginally stable. Okay, so if you have all these points, you get 3 marks. Okay, so basically let's say if your root locus bentuk bulat, for example, so your root locus is stable at this section, and on the JW axis, your root locus will show that the system is marginally stable, and after crossing the JW axis, the system will be unstable. Okay, if you look at the root locus, so the root locus basically represent the value of poles when you vary the value of k from 0 to infinity. So the root locus here, this section here, is from 0 to let's say m. M represent the gain at the JW axis. So this section here represent the value of k from the gain at JW axis until infinity. Okay, infinity means the value of k at poles, okay, at zeros. Okay, so if you look at this root locus example here, the system is stable from 0 until k until m, and system is marginally stable for k equals m, and system is unstable for k from m until infinity. Okay, so for this question, you can either answer by giving example, or you can give some description. Okay, so dua-dua cara pun betul. Okay, asalkan ada 3 point ni, stable, unstable and marginally stable. Okay, so for question B, the student is given a closed loop transfer function and asked to sketch its root locus. Figure 1 shows 3 possible root loci sketched by the student. So the cross X, circle, 0 and arrow shows the pole, 0 and direction of the root locus of the root loci respectively. Determine which one of the sketches are the most possible root locus of the transfer function. Justify your answer. Okay, so if you look at this 3 figure here, figure A, if you look at the direction of the arrow, it shows that the root locus will start from 0 and finishes at poles. So we know that the rules state that root locus starts at pole and ends at 0. Okay, so figure A ni bukan root locus dia, not the possible root locus. Okay, so not figure A. We look at figure B. So figure B, the arrow shows the root locus start from poles and then end at zeros. And it also symmetry about the real axis. Okay, so from figure B, it has all the properties required for a root locus. Okay, so figure B, possible root locus because has all the properties. Okay, so figure C, if you look at the poles here, one at real axis and one on the JW axis, and for the zeros, one at the origin and the other one is on the JW axis. So if you look at the plot of poles and zeros, it's not symmetry. Okay, the poles and zeros are not symmetry about the real axis. So for figure B, for figure C, the plot for poles and zeros are not symmetry about real axis. So not figure B, figure C. Okay? So figure C is not the root locus. So if you have these 3 points here, you get 3 marks. Okay. Okay, question C. Another student is given a forward transfer function, GS, with a gain K1 of a unity feedback system. There are 3 poles and 2 zeros in GS. He only managed to determine 2 poles and 1 zero, which are P1 equals -2, P2 equals 1 minus J, and Z1 equals -1 plus J. So question 1, determine the missing poles and zero. Justify your answer, and then determine the closed loop transfer function of the unity feedback system. Okay, so if you look at question C, it says that GS is the forward transfer function with gain K1. So gain K1, GS. So these are forward transfer function. Okay, so let's say input RS, output CS. And then a unity feedback system. Okay, so this is a unity feedback system. Okay, so your system should have this block diagram. Okay, and then the transfer function GS has 3 poles, 2 zeros. Okay, so from the unity feedback transfer function, you can straight away use the poles and zeros from GS to sketch the root locus. Okay, so 3 poles, you have P1 equals -2 and P2 equals 1 minus J, and 0, Z1 equals -1 plus J. Okay, so the missing pole and 0, P3 is 1 plus J, and Z2 is -1 minus J. Okay, so if you manage to get P3 and Z2 here, you get 1 mark. So reason, justify. So there are two answers. If you answer from mathematical point of view, P2 and P3, Z1 and Z2 are what we call complex conjugate. Okay, meaning that if one is negative J, the other one must be plus J. Okay, so this one plus J, this one must be minus J. Okay, so if you answer complex conjugate, you get 1 mark. Or you can also answer that P2, P3, Z1 and Z2 must satisfy symmetry of root locus. Okay, so if you sketch the poles and zero, so one of the pole is here, and the other zero is here. So to satisfy the symmetry, you must add 1 0 here and 1 pole here. Okay, so if you answer the second answer here, you also get 1 mark. Okay, salah satu. Okay, salah satu dapat 1 markah. And then determine the closed loop transfer function of the unity feedback system. Okay, so firstly determine GS. So GS is S plus 1 minus J, S plus 1 plus J divided by S plus 2, S minus 1 plus J, S minus 1 minus J. Okay, expand, kembangkan. Ya, entah.
Doktor,
Hmm.
numerator tu saya dapat S plus 2S plus 2.
Sorry, tak dengar.
Numerator
Hmm.
S squared plus 2S plus 2.
Plus 2S Yang denominator?
Dia minus 2S plus 2.
Okay, thank you. Okay, so ni jawapan untuk GS. And then for the closed loop transfer function, let's say TS equals, so ada K tadi. So K times S squared plus 2S plus 2 divided by S plus 2, S squared minus 2S plus 2 plus K times S squared plus 2S plus 2. Okay, so kalau dapat GS ni, dan TS ni dapat 2 markah, okey. Okey, tak tulis GS pun tak apa, terus kira TS pun boleh. Okey, 2 markah. Yang penting kena dapatkan dalam bentuk yang termudah macam ni. Ada numerator and denominator. And then question number 2. From the transfer function in C1, determine the range of K1. So ni K1, okay. For the system to be stable, then determine the frequency for the system to be marginally stable. Okay, soalan nombor 2 ni basically dia nak range of K and then dia nak value of K for marginally stable. No, the value of frequency for marginally stable. So you need to use Rauch-Hurwitz table, okay. So the denominator, you get s plus 2, s squared minus 2s plus 2 plus k s squared plus 2s plus 2. Okay, cuba kembangkan. Tak habis kembang, saya ingat tu. Okay, susunkan. Okay, and then from the denominator we use we draw the Rauch-Hurwitz table. So start from s cube and s2. So this is 1 k to k minus 2 to k plus 4. Okay, row s1 you get this is 0, and then row s0 you get 2k plus 4. Okay, for stability, look at first column. Okay, so firstly 2k plus 4 must be positive, so you get k bigger than minus 2. And this is row s0. From row s2 you get k bigger than 0. And then from row s1, ni panjang sikit. Simplifikan. So k equals 2 plus minus And then buat garis nombor. Okay, dah pening dah. Okay, one garis nombor kat sini, satu kat sini, satu lagi dekat sini. Okay, so yang intersect tiga dekat sini. Okay, so for stability, K must be bigger than 1 plus 2 square root 3. Okay, K1. Okay, nanti check, saya pun dah pening dah. Okay, so to determine frequency for marginally stable, so you use this K on row S2. Okay, use K1 equals 1 plus 2 square root 3 on S2. So you get 1 plus 2 square root 3 S squared plus equal 0. So nanti akan dapat S plus minus something J. Okay, rasanya jawapan dia 1.8 kot, 1.82. Okay, so this is the frequency for marginally stable. Okay, for this question, if you construct the dark orbit stable, you get 2 marks. Finding the range of K, yang ni 3 kot, 3. Finding the range of K, you get another 3 marks. And then find the frequency, you get 2 marks. Okay. Okay, question number 3, determine the angle of departure and arrival for P2 and Z1. Okay, so firstly we do for P2. So P2 is here and P1 is here. Oh no, P3 and P1 is somewhere here. And then Z1 is here and Z2 here. Okay, let's do for P2 first. So you need to determine the angle from all of the poles and zeros to the pole P2. Okay, so here it's this angle theta 3 equals minus 90 degree, and then from this pole it's this angle, so angle theta 1 here, so theta 1 equals minus tangent minus 1 1 over 3. Okay, and then the angle from theta to Z2 is basically 0. Okay, angle is 0. And then angle from Z1. So angle Z1, let's say so Z2 is 0. So angle Z1 equals minus tangent minus 1 2 over 2 1. Okay, 45 degree. Okay, and then angle of departure equals formula dia apa lupa dah. 180 plus theta z minus theta p. So you get 180 plus minus 45 degree minus minus 90 minus tangent minus 1 over 3. Okay, this is for departure. Okay, so angle of departure is for poles, okay? And for 0, it's the angle of arrival. Okay, so for the angle of arrival Z1, so for Z1, the angle from poles P3 is 180. So theta P3 equals 180. From theta Z2, it's 90 degree. From theta P1, it's this angle. So theta P1 is tangent minus 1, 1 over 1. Okay, 1 over 1, 45 degree, correct. And theta P2 measured from here. Okay, so theta P2 is 180 minus tangent minus 1 minus this angle. So that angle is 2 over 3. 2 over 2, 45 degree juga. 135 degree. Okay, so for theta AZ, theta angle of departure, angle of arrival Z1 is 180 plus, tengok balik formula, lupa. Theta P minus theta Z, okay. Okay, so 2 markah untuk angle of departure, 2 markah untuk angle of arrival. Okay, question number 4, sketch the root locus. Okay, sketch the root locus. You have one pole here, minus 2. Here, the zeros. And another pole here. Okay, so angle ni tadi ni dalam 90 darjah kot. Yang ni entah. Okay, so the breakaway and the JW axis crossing is somewhere here, 1.8. Okay, so to sketch the root locus, you must make sure that you have the correct number of branches. So you have 3 poles, means you have 3 branches, and then start from x zeros and then end at start from poles and then ends at 0, and then symmetry. Okay, so the root locus will be something like this. Okay, dia arrive menegak. Okay, so the direction is from poles to 0, and then another branch is from this poles here to infinity. Okay, if you get 1 mark for uh, plotting poles and zeros. And then 1 mark for symmetry, and 1 mark for 3 branches. Okay. Selesai. Walaupun tak berapa jawab semua. Okay, so that's it for your take home quiz. Oh, nak kat pukul 10 dah. Okay, so that's it for root locus punya topik. Okay. Okay, for exercise, can you continue this question take home quiz number 2? So for exercise, okay, tak payah hantar. So continue take home quiz RL number 2. Determine whether the point x equals -3 is on the root locus. Then determine the gain at this point. Okay, try buat soalan ni sebagai exercise, okay? From take home quiz root locus number 2. Okay, so that's it for root locus punya topik. So this Wednesday we will go into new chapter, insyaAllah, and then maybe next week dah habis lah lectures, okay? So thank you siapa yang remind tadi suara tak dengar. Okay, sorry, lupa nak buka mic. Okay, so if you have any question so thank you for